Hey y'all, Data Guy here. And today I have a video for you where I'm going to be going into and breaking down Airbnb's newly open source observability platform, Chronon, with an eye. I'm kind of talking about why companies develop their own internal tools, like why a company like Airbnb would effectively develop its own product that they're now open sourcing versus getting something off the rack, buying something from a cloud provider, buying an observability platform. And what's really cool about this is because it's now open source, I can actually run this locally on my machine and give you guys a little walkthrough through it as well. So got some requests from you to do more, real world use cases. This is truly a real world use case where Airbnb has built this observability platform to help run their business, and now they're making it available for other people to help run their business as well. So thought this would be an interesting one to start with. But if you have any other ideas or companies you'd like to see, learn about, let me know in the comments and I'll try and make a video on them. Without further ado, let's get into it. So at its base level, what is Chronon? Chronon is an end-to-end feature platform that is meant to allow machine learning teams to easily build, deploy, manage, and monitor data pipelines for machine learning. And it's used to power all major ML applications within Airbnb, and as well as some major use cases at Stripe. And Airbnb and Stripe actually have jointly managed and maintained the project up until now, where they've opened it up for open source use. And you can kind of see the general flow of this platform, and don't worry, we're going to get into it so you'll see kind of how it works in action. But the idea is it's going to take this data from a variety of different sources, have a way to define features on them, what type of things are most predictive within those data sets, what can be best used for machine learning applications, and then serve those features to endpoints, provide training data, and then have observability and management on the various features that you might be looking at. Because if you've worked in modern ML, observability and managing these pipelines at scale is a really beefy problem. And so you really need to develop platforms like these if you don't already have them to manage all of them at scale. And so some key guiding principles for this platform and some reasons why they built this themselves instead of getting something off the rack is they had some key features they wanted to develop. Number one, being able to consume data from a variety of sources. So event streams, batch warehouse tables, production databases, change data streams, service endpoints, and any other data available in the request context can all be used as Chronon inputs. Then, they wanted a way to easily define transformations and aggregations, so raw data ingested from sources can be transformed into useful features using a flexible library that doesn't require proprietary things. Another feature they wanted to make sure was included was the ability to produce results both in online and offline contexts. So online for scalable low latency endpoints for feature serving to other teams or across the organization, and then offline as Hive tables to power model training and evaluation flows where the data is actually living right alongside the ML model, so you don't have the IO costs of needing to serve from an external location. Then fourth, you had real-time and batch support with online-offline consistency as well. So Chronon not only supports real-time and batch updates to its online KV store that's used to power production interference models, but it also provides temporally accurate backfills in the offline context. And what this means, it's obviously complex, kind of more jumbo, but it means that training data is always going to be consistent with production inference data because those temporally accurate backfills, that just means it knows, hey, if I need to backfill data because it was processed too late, I know exactly when to insert that data into that previous historical data. And then fifth, it has a really powerful Python API, so it has the ability to define your features in a very simple and intuitive Python interface, and Chronon abstracts away the complexity of the actual computation serving of those features. And then finally, the final kind of big feature is automated feature monitoring. It has the ability to auto-generate monitoring pipelines to help understand training data quality, measure training serving skew, and monitor feature drift as well. So now that you know some of the driving characteristics, the reason why Airbnb developed this platform, what the platform does, I want to actually show you it. So luckily, Airbnb was kind enough to make this available in kind of a quick start tutorial. So I'll have this link in the description below if you want to follow along. All it requires is Docker. So next, I'm just going to pop over into my local development and we'll get started. So the process to get started with this is pretty easy. Just go open up a code editor. Don't even really need to do this, honestly. I'm just doing it because this is where I usually work with terminal. And then I'm going to cd into desktop, repos, and just quick make a directory in case I actually need to do anything with this install. So make directory Chronon, cd in there. And then from within this directory, I'm just going to execute a curl command to download the Docker Compose file. So here, downloading the Chronon Docker Compose file, and then we can type in Docker Compose up. And then once we see some things confirming that only showing top 20 rows, we'll be ready to start the tutorial, but I'll wait for this to download and come back once it's done downloading. So here we have that magical only showing top 20 rows, which is exactly what we're looking for here. And you can see, I just want to go over some of the components spun up. So you can see we have Mongo, a local environment, Kafka local environment spun up, Zookeeper, manage the Kafka. So now let's actually try running into it. So first thing we're gonna do is open a new terminal window and open up a shell session to interact with it. And so to do that, what we will do is just docker compose exec main bash. And interesting, oh, we gotta go back in that folder, so 1 second. And Chronon, and then this should work here. Awesome, so now we are in the Chronon environment in that command line. So now we can start doing some fun things. And then let me also open up the folder structure we installed. So desktop, guy Chronon, and here we have the Docker Compose YAML file available within this directory. So that's what we're actually referencing. So if we go in here, you can see this has all the different Docker containers that we're spinning up. So Mongo, Zookeeper, Kafka, and then the main shell script, which is the actual core Chronon server. And so opening up terminal again. Where are we? Okay, cool. So now I'm actually going to open up another shell script because it deleted my shell script session. So 1 second. So here, compose. There we go. Awesome. So now the actual scripts that they use to define the logic of this quick start are baked into the image, so you won't see them. You just see that Docker Compose file. So I wanted to quickly just pull up this show you what the actual data that we're going to be working with here is. So essentially what this first script is doing that's baked in is it's going to aggregate user data, log data on, so what each user is doing, giving a view into that user's activity on the Airbnb platform. So essentially that's the core of what's happening, just aggregating the various purchases, various purchase prices, what they're doing on the platform, some basic information, and just using generic kind of endpoints like group buys that people have already set up, right? Everyone's used group by, everyone's used aggregate, things like that are pretty part and parcel. And then what you have is also this here, you will have the ability to turn user data into features because the primary key of the source data is the same as the primary key of the features. You're just extracting the column values rather than performing aggregations over rows. And you can see here, we're just selecting the fields we care about, which are user ID, when was the account created, is the email verified, and then down here, we're going to join all the features together. So all the features that are defined, let's backfill them. So use the backfill functionality of Chronon to pull all the data over a historical time period and then join it all together. So here you can see the primary key we're using is user ID, and then it knows to get all of the purchases, refunds of that user, using that user ID to then include that all into one training set that we're going to use to then train the data. And now we can go back to, I just wanted to show you kind of the process that Airbnb defines as quick start for actually just joining the data because they don't expose that. But now we can start compiling it and actually using those commands within the context of Chronon. So now let's go back into our local development environment. So the first command we're going to run here is just to compile that training set. So if we run the compile.py, it's going to reference that script I just showed you, and then it's going to write the resulting data sets to this directory here. Then the next step, sorry, let me move my screen up again, is we are then going to convert that into a thrift definition. So this is be converted into a thrift definition that we're then going to submit this to Spark to then get processed. So here, submit to Spark, and awesome. So now it's using that local Spark cluster that it's spun up alongside, running that join analysis. You can see running that query, so selecting all that data, doing the checkouts, validating the permissions, Iceberg, because it's using a data lake underneath. So see all these different open source technologies all chained together into this one tool. So it's pretty cool, honestly. And the output of this backfill, you can see here, is going to contain the user ID, or it should contain our user ID. So here you got record 1, and then all the different columns of what they've done. So here, purchases some over 3 days, 14 days, 30 days, purchase price count, purchase price average. So all the information needed around a certain person. You can see just kind of 2 example records for these top 3 rows. And now we can query that backfill data using Spark SQL. So we have this really easily ML feature engineered data that we can then query however we want. So if I then go Spark SQL, type that in, and then once we're done with this, so here, and then here we're going to run a select statement. So what we're going to do is just select a few different columns. So selecting user ID, quick start returns, just limiting it down to not the entire data set here. And then here, Spark is going to select and give me all of those rows, first 100 rows here of the different user IDs, and what else we get? Is email verified? So email verified is this 01. You have the purchase price over 14 days here, and then you also have your refund amount over 30 days here. So really cool stuff. And then you can exit the Spark's shell by just running quit down here. And then, so we've created our join, we've backfilled the data, it's really easily queryable. Now we're going to train a model. So what we'll next do is actually upload the data to an online model. So our next step is going to be we're going to take that data we uploaded into our online KV store. So instead of a backfill, we're just going to update the most up-to-date feature values for each primary key. So this is going to really just use MongoDB and the Docker image, but it would, in practice, you probably want to use an online transactional KV store. So here we're going to upload the purchases group by. Incredible. And then what we'll do is submit a Spark job to actually upload it into the database. So here, Spark cluster, and then boom. So submitting that Spark cluster to load it all into Mongo. So here Spark is going to load our group data into Mongo as well. This is just the purchases data. So after we're done with the purchases data, then we're also going to upload the return group by data. So here, next step, run group by. So basically it's doing the same exact thing, so I won't spend too much time here. Just showing you the process that you really need to go through to upload, train the data, and do every step of the machine learning model all through Chronon. And awesome, so that's done now too. And then we'll do Spark submit. And here, this is going to submit that to that Spark cluster as well. I'll just pause it until it's done. So now our data is uploaded into MongoDB. We're then going to join the metadata. So here, just going to upload the join metadata as well, so it knows what to join on, which everything is linked, so we can use the fetch join API. And then now we can easily fetch vectors with simple API calls here. So this is the whole we've all been building to. So here we're going to just fetch a quick join statement. So on user ID 5. And boom, now you can see all the different vectorized data for user ID 5. And then if I want to, let's say maybe fetch a single group by, fetch the single group by here. And so here again, just fetching a user ID 5. And you can see nice group data fetched in 404 milliseconds. And yeah, that's just really it. It is, there's some other things you can do, log fetches. Actually, yeah, let's go through some log fetches as well. So what we'll also do is create a usable log table. So 1 second, let me run these. There's a series of commands here we're going to need to do to just do a usable log table. So now that we've done some actions within this database, I'm then going to show you how this is going to create a table dictating all of our different actions, which is the endpoint. You want to be able to see what all your users are doing. This is why companies like Airbnb would do this. As you can see here, it's going to build this all out, series of different things. So you can see partition by, schema hash, saying that it's within Chronon. And you can see my one row of logs, because it's just a single user. You can see all the actions that I performed, the queries I performed, and just have all this super available historical data. And now that is one thing that's good, but then we also have consistency metrics. So we can see how well our system is performing over time. So the last thing for monitoring. So here, what this is going to do is basically take the primary keys and timestamps from the log table and then use those to create and run and join backfill. And what this is going to do is compare the backfilled results to the actual log values to make sure, hey, is our backfilling actually staying consistent? And then produce two output tables, which is the quick start training set consistency, which is a human readable table that's like queryable to see the results of consistency checks. And then a separate consistency upload table that's a list of KV bytes that meant to be uploaded to the online KV store, which then can power online data quality monitoring workflows, because you can feed that raw data directly into those data quality monitoring tools. So that's really what I wanted to get into today. Just to show you, hey, this is what some real world companies do for their data engineering tools. They build these proprietary platforms, and it provides them a lot of benefits because they have the ability to basically define whatever kind of workflows they want, include whatever tools they want. They can change everything. It really exemplifies how a well-designed, proprietary platform can help address the complexities of really customer-specific issues. If you have the engineering brain power, you can build these tools that are really powerful for your company instead of just kind of buying off the rack. However, the downside is, engineers that maintain this, they're going to get paid a lot if Airbnb wants to actually, maintain this tool. But that's also some of the appeal of open source, is that you can say, hey, the community can help me maintain this. And that's really what happened with Airflow too. Airflow started at Airbnb, or maybe, yeah, it was Airbnb. And then, it got open source, and now it's a huge global tool. But there's still a couple data engineers at Airbnb that get paid like a couple $1 million to maintain their own Airbnb flavor of it. So just a little fun tidbit for you. Anyways, that's all I have for you today. I really hope you enjoyed this video. Hope it's the start of a new kind of series. And I hope you have a great rest of your day. Data Guy out.